Okay, so we move to the second exercise, which is about Voronoi or Thyssen polygons. Yeah. In that case, we also use as the inputs a point dataset, but the objective is a bit different. The objective is not to detect whether we are having a specific cluster or dispersed pattern. Here, what we're going to do is to estimate, calculate areas of influence. The objective for this could be basic, for example, for meteorological purposes. Just imagine these are meteorological stations, and then we don't know for maybe which is the rainfall in one specific area, and then we want to rely on the closest meteorological station. So we create these areas of influence, yeah, estimated area of influence for this meteorological station in order to apply what this station, this sensor is measuring to its area of influence. On that way, we can also estimate areas where or areas which are actually very far from a specific station, and the installation of new stations are required in order to reduce these Thyssen polygons and areas of influence. Yeah. For example, in the case of hospitals or telecommunication networks. So while doing this analysis, we might also be able to identify areas with low coverage, or because they are very far, and more stations, and basically identify areas where more stations are required, are needed. Okay? So, but what is important for us now, you can read, of course, about the applications of these Voronoi and Thyssen polygons. These are common, very common use tool using in GIS specifically for, you will see this a lot in meteorological data, but in any case, we need to learn how to calculate these polygons. ArcGIS or Quantum GIS is going to do the analysis for you, but it's a very simple analysis, so let's do it. First step is to link the different points, yeah? To link the points to the closest neighbors. So we create those links, yeah? Okay? There is always a priority when the links are closer. So if we have to decide which first rule is the links cannot cross to each other, they cannot intersect, yeah? So which is the priority? The priority is always to draw the link which is closest, smallest in length, yeah? So between these two, yeah, we have to decide in one of them, and the decision will be based on the length of those links. Okay, so this is the first step, and then the second step is actually, again, very simple. We need to calculate the bisector. That means the perpendicular in the middle point of those links. So if the middle point is that one, yeah, the same distance here and there, this is D. So this is D by 2, D by 2, yeah? And there we just draw the bisector. It's a bit confusing if you have to do it manually, but in any case we are just going to learn the basics. So this is the bisector, so this is, sorry, the middle point, this is the bisector. Okay, let's do it only for the central point, but the same mechanism should be replicated for the others. So for the central point, the bisectors should be drawn one here, one here, one here, one here, one here, and one here. So you can see this is the area of influence for example, this meteorological station, yeah? So this is the area of influence. What is one of the properties of this area of influence? Any point located in this polygon, within this fission or polygon of Voronoi polygon, will be, any location will be closer in distance to this point, to the one inside the polygon, to any other in the data set, yeah? And then points on the border of the polygon will be equidistant.